Hi, it's Terry Denner in the MathWorks. I'm going to do a math problem now. It's an infinite series. And again, my son gave me this one and thought about it for a long time. I'm really fascinated that in infinite series where the terms remain finite for a very long time, that these series can actually converge to finite values. It's kind of cool how all this works. And generally, there's some sort of trick where the term gets repeated, but it kind of ends up with a minus sign the next time, and a lot of cancellation can occur, right? And so anyways, I took a look at this one, and I go, have no idea. I thought about it for a week, and I kept on trying to figure out, well, how do you convert this into an integral? And then I can just apply all these integral methods. And so then all of a sudden I thought, well, why does it need to be an integral for me to do partial fractions, right? And so the basic idea of this is to break it up, kind of do the partial fraction thing, and you get kind of these A and B coefficients that need to be figured out. Turns out that they're both equal to, well, one's equal to 1/5, that's A, and B is equal to minus 1/5. And as soon as you get to here, you're beginning to see it. You can break it up into two infinite sums, and you realize that they're almost the same thing. It's just that one starts at 1 and the other one starts at 6, and it really means that the converged value is merely the first 5 terms. All right. So again, you kind of work through some of these things, especially if you're not familiar with infinite series, and you just think, oh, these things are kind of miraculous how well they work. All right. And so I think the role for MATLAB, perhaps you'll do something with symbolic toolbox or whatever we call it now. But to me, I think there's a validation piece that was very interesting to me. So I'm going to just kind of copy this. And let's go to MATLAB. Oh, here's my practice run. So I'm going to just say, no, I don't need to save that. And in MATLAB, I also want to just kind of clear my workspace. And let's open up a live script. Okay, and I'll just hit Control E, get into talking like a person mode, and I'll paste in that. And I think I'll say which reduces to, okay, let's go copy that as well. And so I'll copy that in, Control C. And I'll paste that in like that. Okay, and now let's get back into code mode. And so Control E, and then it's Control plus zooms things in and makes it a little bit bigger. And I think that'll be big enough. I will just kind of move this maybe to about there. All right, and to me it begins with N, and I mean big N. All right, and we're going to let big N get real big, but for right now, we're just going to establish it. And so I'll just say it's equal to 100. Right? And what we're going to do is set up a sum, and we'll set that sum equal to 0 to begin with, and then we'll just do a for loop. And so for N equal 1 to big N, we'll say sum is equal to sum plus 1 divided by n divided by the quantity n plus 5. And we'll put an end in there, and then we'll just kind of unsuppress the expression of sum outside the loop, and I'll hit F5. How do we do? Okay, 0.447. All right. And so now I want to run it for 1,000 terms and for 0.4557. So it looks like we're beginning to converge as that number gets big. And we actually got a good way of looking at that. All right. And so what I'm going to do now is say x is equal to 1 colon n, and y is equal to zeros 1 comma n. All right, and so we'll have a means to plot this. And so essentially each time through, I'll assign a new element of this Y array equal to the current value of sum. Okay, so hopefully that makes sense, but I think it'll make a lot of sense when I do this. And I'll just plot x comma y. All right, and with that, I'll hit F5 for running it. And there you go. We see kind of that convergence, and certainly it's converging to something that sort of looks like 0.4557. Why don't we try it with 10,000 elements? And hit F5. And we're certainly converging, right? And so now what I want to do is, I think the way I'll do this is let's do the exact solution. All right. So the exact solution is the summation down below here. And it's kind of neat how much simpler it is. Right. And so I'm going to call this sum exact. All right. And that will be initialized to 0. And then we'll do a for loop in equals 1:5. And that sum exact plus 1 divided by 5 divided by n. I think I got that right. And we'll do a sum exact like that. All right, and so we hit F5 to automatically run it, and 0.4567. And certainly if we make n equal to 10,000, we're getting really, really close. All right, and I'll just kind of finish this last part up and kind of include that in the plot. Might be a better way than the way I'm going to do it, but this I know will work. All right, and so I'm going to call it x exact is equal to 1 comma n, and y exact is equal to sum exact. I think I got it. Kind of was fumbling around a little bit there. Let's hit F5. And you can kind of see it. Now it's better to kind of look at this with a much smaller set of n. And I'll hit F5. Okay, and anyways, I think that's a nice role for for MATLAB on this type of problem. I'd say the formulation is really cool. I did find a really cool Khan video on this, where he's using basically partial fraction decomposition to find the sum of a telescoping series. Not exactly sure where they call it that, but I think I'll even put that into my live script too. And so let's just write something like this. Right, Control E for theory on partial fractions and infinite series. See Khan video. I'll just paste that in like that. So, all right. Anyways, there's a good math example. Thanks for watching. Please offer some comments. Again, it's been a lot of fun to put these videos out there, and I already have been getting some really good comments. Thank you very much.